For me, being part of Marie Skłodowska-Curie Action is a truly transformative experience. It is more than a fellowship. It provides a structured and inspiring environment that challenges me to rethink how I approach science, connect different disciplines, and refine my long-term research vision. What I value most is the program's commitment to translating scientific findings beyond the laboratory, making sure that our work contributes to real clinical and societal needs. Participating in the Marie Skłodowska-Curie program has given me the chance to pursue three major opportunities at once: international mobility, interdisciplinary research, and the strong scientific networking. For many years, I worked in Turkey in the fields of toxicology and natural compounds, focusing on olive-derived bioactives, a central component of the Mediterranean diet. This has enabled me to investigate not only the cardioprotective effects olive tree bioactives against drug-induced toxicity, but also to explore their broader potential to strengthen the body's resilience and offer long-term protection against diseases like cancer. Working in an environment where biology, engineering, and clinical science naturally come together has greatly enhanced the impact and quality of my project. The main objective of the OleoCardioSafe project is to determine whether bioactive compounds from the olive tree can reduce or prevent chemotherapy-induced cardiac injury. To achieve this, we use human-induced pluripotent stem cell-derived cardiomyocytes, endothelial cells, and fibroblasts. We integrate these cells into a microfluidic heart-on-a-chip system that mimics how drugs reach and affect human cardiac tissue. In parallel, we will perform in vivo experiments. These experiments allow us to evaluate drug-induced cardiac dysfunction and observe the protective effects of olive-derived compounds in a whole organism. By using induced pluripotent stem cell-derived cardiac cells in a microfluidic heart-on-a-chip system, we can test the effects of chemotherapy drugs as well as other treatments that might pose a risk to the heart. In this setting, bioactive compounds from the olive tree could provide an extra layer of safety for patients undergoing treatments that can harm the heart. These olive-derived compounds are known for their antioxidant, anti-inflammatory, and mitochondrial protective properties. At the societal level, ensuring that cancer treatments are safer for the heart can lead to better long-term outcomes, fewer treatment interruptions, and a significant improvement in quality of life. In the long term, integrating patient-specific iPSC lines into the platform may allow us to tackle cardiotoxicity in a more personalized way, offering safer and more tailored strategies for high-risk patients. For me, science has always been more than a profession. It's a way of finding purpose. I entered this field because I wanted to understand how living systems react to stress and how we can protect the body at its most fragile moments. The idea that a discovery, even a small one, can eventually make someone's life safer or better is incredibly inspiring. Looking ahead, I hope the knowledge generated through OleoCardioSafe will pave the way for safer and more effective cancer treatments. I expect that the protective pathways we discover will move beyond the laboratory and eventually become part of actual clinical practice. Ultimately, My wish is to see a future where life-saving cancer therapies no longer endanger the heart. In that future, human-based, personalized testing models would guide a new generation of cardioprotective strategies.